Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about confidence interval for the mean when the population standard deviation is not known. I'll share my screen. The following information was collected from a random sample of students on how many hours they spend per week watching TV. And these are the data points 0, 3, 1, 20, 9, 5, 10, 1, 10, 4, 14, 2, 4, 4, 5. Assuming this sample data came from a normal population, construct a 98% confidence interval for the mean amount of time per week spent by the students watching TV. Okay, so I will solve this problem in two ways. First, I will do it using formula, then I will use a calculator. So, solution. Enter data in L1. Okay. So you know the procedure for then stat. No, we will not do stat. So just this. So basically press the second button, then the plus button. Where is the plus button? On top of the enter button on the bottom right corner. Second plus, then select number 4 and you get clear all list. You are going to hit enter and then you'll see done. That means memories of the calculator has been cleared. Okay, so let's do that. Second plus 4, clear all list done. Then you're going to press stat. Then number 1, so stat button, and then number 1. So enter data in L1. So put your cursor in L1 and then end the data points, which are 0, 3, 1, 20, 9, 5, 10, 1, 10, 4, 14, 2, 4, 4, and 5. So 15 data points. So we entered data in L1. Okay. So enter data in L1, which we already did. Okay. Now press the stat button. Stat button. And then highlight. Highlight means move the right cursor on top of calc. Put the cursor on top of calc in the top row. And then select number 1. Okay. And you will get in your calculator screen 1 var stats. Var stands for variable. Okay. First line in 1 var stats is list. It is automatically set to L1. Next line is frequency list. That should be empty. If there is something on here, hit the clear button. Okay. In the second line after the colon. Bottom line, it should be empty after the colon. And then we have the calculate. Okay, put your cursor on calculate and hit enter. So we are interested in X bar, which is the sample mean, and that is equal to 6.133. We are also interested in Sx, which is the sample standard deviation. Sample standard deviation. Okay. And that is equal to 5.514. Okay. Notice this is a sample data, so we are interested in Sx. We are not interested in sigma x, which is population standard deviation. Okay. Since the population standard deviation is not known, population standard deviation is not known, is not known. Use formula for T interval. Okay, so confidence interval for the mean, population mean, is given by x bar plus minus T alpha by 2 multiplied by S divided by square root of n. Now, in this formula, T alpha by 2 is the critical value of T. Critical value of T. And alpha, this is alpha, this is level of significance. It's the complement or opposite of level of confidence. And alpha, because it's complement of level of confidence. Alpha is the level of significance, is the opposite of level of confidence is 1 minus C. So in this case, 1 minus 0.98. So alpha is equal to 0.02. Now, let me create some space. Okay. And so if we draw the T distribution, it's a bell-shaped distribution. Okay, in the center you have T is equal to 0. So the horizontal axis is T axis. Vertical axis, of course, probability. So our confidence level is 0.98, which is like this. So area in the center is 0.98, and that is equal to C. So C being this, alpha is 1 minus 0.98. So alpha is equal to area in 2 tails. So area in each tail. Tail means the left end and the right end, is equal to alpha by 2 is equal to 0.02 by 2 is 0.01. So area of this tail, area is equal to alpha by 2 is 0.01. And similarly, area over here, area is alpha by 2 is equal to 0.01. So this critical value of T, it's called critical value because it separates the least probable region from the most probable region or the confidence region. So that's why it is called critical value, and this is equal to minus T alpha by 2. The reason it is negative because it's on the left of 0. And this one is positive T alpha by 2. So this one is negative and this one is positive. Now, another thing we have to be careful about in T distribution is degrees of freedom. Degrees of freedom. And that is equal to, is also known as df is n minus 1. So here we have 15 samples, 15 minus 1, degrees of freedom is 14. Okay, and minus T alpha by 2 and T alpha by 2 are the critical values of T. Critical values of T. Okay, how do I find minus T alpha by 2 using the calculator? Well, you press the second verse and scroll down to number 4. So second button, then verse button, then scroll down with the down arrow key to number 4, which is in T, and hit enter. So they ask for area. This is area in the left tail is 0.01. Then they ask for degrees of freedom, which we know is 14. So type for the area 0.01. Area is 0.01 in each tail. Degrees of freedom is 14. Then go down to paste and hit enter and enter. Okay. So let me create some space for myself. Okay. 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 So we put it on paste and enter and enter. And minus T alpha by 2 comes out as minus 2.624. By symmetry, T alpha by 2 is 2.624. This is the critical value of T which we will need in our calculation for the confidence interval. Remember, confidence interval formula interval is x bar plus minus T alpha by 2 times S divided by square root of N. So let's plug it in our formula. X bar is equal to 6.13, okay, plus minus 133, plus minus my T alpha by 2 is 2.624, multiplied by standard deviation is 5.514, and divided by square root of sample size, which is 15. Okay. So let's calculate this. So this is 6.133 plus minus, let's do the calculation, 2.624 multiplied by 5.514 divided by second button, and then x square gives you the square root. Inside the square root, sample size of 15. So this is plus minus 3.736. Now, this whole thing is called margin of error, or some book call it error bound margin. Error bound margin. Okay. So if I may create some space. So my confidence interval, 98% confidence interval for the mean. Confidence interval for the mean. For the mean is 6.133 minus 3.736, and this is the lower bound, lower boundary, comma 6.133. plus 3.736. This is the upper boundary. So let's do the calculation. 6.133 minus 3.736 is 2.397, comma 6.133 plus 3.736. This is 9.869. So these are the two limits of the 98% confidence interval. So if I create some space, write the meaning of this. Okay. So with 98% confidence, we can state that the actual population mean will fall between 2.397 and 9.869. Sorry, 9.869, not 8.869. And 9.869. Okay, so this is the long way to do it. There's a short way to do it. Short way with TI-84. We have already entered the data in L1 and we do not know the population standard deviation. So this will be a calculation for T interval. So let me create some more space. Okay, so let's press the stat button. Then highlight the test button, move the cursor in the top line to test. Okay. And then scroll down to, with the down arrow key, to T interval. Okay. And hit enter. Okay. Now in T interval, input should be data. Put the cursor on data and hit enter. Input data and hit enter, so the cursor is flashing on data. Okay. List is automatically set as L1, where we have entered the data. Frequency is automatically set as 1, do not touch it. Sea level is what we have to change. Sea level will be 0.98. So change the sea level to 0.98 and then bring the cursor on calculate and hit enter. Okay, and you get more or less the same answer, 2.397, comma 9.870. So this is the 98% confidence interval as obtained from the calculator. 98% confidence interval. The lower boundary is 2.397, the upper boundary is 9.870. It's exactly identical to what we did using the calculation, doing the calculation by hand. So I'll stop here today. If you have any question, comment, please write me a note. I'll appreciate that. If you like this video, please give me a thumbs up. I really appreciate it. If you have any question, let me know. I'll get back to you as soon as possible. And if you like this video, please share it with your friend. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. Take care. Have a nice day.